Alright, welcome back. This is Thermodynamics II at South Dakota School of Mines and Technology. We're on homework 4, which is fugacity. Okay. Number 3 asks to derive natural log of phi using the following equation of state. Okay, and there's the equation of state, where A equals some stuff and B equals some stuff. But actually, because they're constant, they won't make any impact on the math of fugacity, so we're just going to leave it at that. Okay, so first thing I do, I recognize this is a vapor fugacity problem. Okay. Number 2, is this pure or not? Well, I look at this guy and I don't see any hats, so, well, that's pure. Okay, so, it's definitely pure. No hats means no party, which means all by my lonesome, which means I'm pure. Okay, now I need to ask, okay, do I have an equation of state? Am I steam, or do I have correlation tables? Okay. Well, I don't, that's not steam. It's not correlation tables. I mean, I have an equation of state, so it's not correlation tables. So we do equation of state. Now I need to decide which equation do I use. So I got natural log of phi, which is equal to z minus 1 minus natural log of z minus v to infinity to v z minus 1 dv over v, or natural log of phi is equal to 0 to p, z minus 1 dp over p. Okay. Which one do I use? Well, this is really easy, actually. All I have to do is I need to convert that to z and then see what's left. Okay, so let's convert that to z. So z is equal to pb over rt. So I'm going to multiply this thing by v over rt. Okay, so I've got v over rt times rt over v minus b minus v over rt times a over tv squared, and then I simplify it out. So I have equals v over v minus b minus a over rt squared v. Okay, nothing crazy. There we go. And then I say, oh, well, what's left? Well, what's left? V's. Okay, so I have V's. I don't have any P's. What to speak of? So I'm going to use the one that has V's. Okay. I've chosen my equation. Now I just plug it in. So let's just erase that stuff and plug it in. Now, with the z minus 1, okay, well, yeah, I could clean that up, but sometimes I just want to leave it as z minus 1. Same thing with this z. I just want to leave it as z. Really what I want to plug it into is just the integral. Okay, now we might clean up stuff with the z minus 1, but for the most part, yeah, whatever. I have z. I can just calculate it. Especially that natural log of z. If I'm already going to calculate z, there's no need to, clean things up. So this is, I know that's what Koretsky does, but almost kind of drives me nuts a little bit, because it's like, he's making more work for you, I think, sometimes. So yeah, let's just leave that as z minus 1, and let's leave that as natural log of z, and I just want to plug things into here. Now, I am going to get z minus 1 out of this thing, but... Alright, and so my integral from infinity to v of z minus 1, okay, so I got v over v minus b minus a over rt squared v minus 1 dv over v. Okay. And so I'm going to divide that v out, okay, and then do my integral. So I've got infinity to v of 1 over v minus b minus a over rt squared v squared minus 1 over v dv. Okay. I could combine these two terms, but I think that actually makes it messier, so let's not. We'll combine them later. Okay. And so I do my integral, I get natural log of v minus b minus, or plus actually, a over rt v, t squared v. T squared v. Okay? So I get, a over rt squared v. Okay? Minus natural log of v from infinity to b. And of course I need to plug things in to see what happens. Okay, before I do any messy nonsense. Alright, so let's do that. Okay. And we'll keep that, because I might combine it with that natural log z. Okay, when I'm all said and done. Let's just do this integral really quick. So, well, I have those two that I can combine. So I have natural log of b minus b over b plus a over rt squared b minus natural log of infinity minus b over infinity minus a over rt infinity. Well, what is infinity minus b? Infinity. What's infinity divided by infinity? 1. What's the natural log of 1? 0. What's a over infinity? 0. Okay. So when I'm all said and done, I have those two. Let's combine it back in, and I have natural log of phi is equal to z minus 1. Again, I'm just going to leave it as z minus 1. Plus, because I got this natural log, and I'm going to combine with this z. So, but actually, it's going to be, this is going to be flipped because this was a minus. Okay. And so, I'm going to have, minus natural log of z times v minus b over b. Minus a over rt squared b. Oh, is that right? Oh, yeah. Yeah, and then I'm done. I might have made a mistake in the integral. I'm looking at it and something seems off, but for the most part, I'm good to go. So. Again, the core steps are identifying the equation. Okay, the integral is kind of minimal.